Hey everyone, we're here with Richard from GoTenna. He'll be doing a talk on mesh networks in a Mad Max world. And once he starts talking, can you guys confirm that you can hear him?
Okay, so hi everyone. I'm Richard Myers. I'm a co-founder of the Global Mesh Labs initiative. Let's see, I guess we'll wait for some confirmations, but I assume you can all hear me. I'm the co-founder of the Global Mesh Labs initiative at GoTenna, and I work as a software engineer developing tools that leverage the Bitcoin network to incentivize decentralized communication. Great, thanks, Victor. So this is a concern people frequently have about Bitcoin, is that it depends on the internet and what happens when there is no internet. Well, in many parts of the world, that's actually the state they're living in. And that's because the internet is either financially out of reach or is unavailable. They're in some last mile community or just some place with very poor internet. So, in those places, running your own Bitcoin full node is going to be prohibitively expensive for most people, and using mobile, metered mobile internet connection, even despite Bitcoin's strong focus on minimal resource usage is going to be difficult. In particular, people in the developing world are much less likely to have a computer at home. So they're going to rely on cell phones, which as their primary way to access the internet. In many parts of the world, people will not, have a dedicated home device to be their full node. So we're actually looking at ways to basically, not just a mobile first, but a mobile only solution that can help Bitcoin users communicate with each other. There's also the problem of surveillance. Metadata surveillance, as Edward Snowden showed, can be used to build a dossier of who is talking to who, even if the communication itself is encrypted. And metadata about our financial transactions can reveal some of the most intimate details of our lives. We strongly believe that there should be a presumption of privacy in people's communications, which frankly just doesn't exist with the normal centralized communication systems we have now. So people living in oppressive regimes also are the ones who need Bitcoin the most. They're the ones who are at the most risk of censorship. And centralized communication networks provide an easy kill switch to switch off the network for politically motivated reasons. And especially if something like Bitcoin is seen as a threat, it'll also be blocked. So we're not looking at just censorship resistance for Bitcoin, but for communication as well. So one way users can reduce their dependence on these centralized communication networks is by confirming Bitcoin transactions without direct access to the internet. And this can be accomplished by confirming Bitcoin transactions in some trust-minimized way using long-range radio broadcasts that can still work even when the local internet is down and can even reach across national borders. Some examples of this, one was actually tested as far back as 2014. This was the Crypto Radio project, which was a pioneer in transmitting Bitcoin data using terrestrial digital television transmitter. This was done in Finland. And that trial lasted only 2 months, but it reached 5 million people. The coverage of that broadcast reached 5 million people, which is 95% of the Finnish population. So for the first time, you could actually validate transactions without an internet connection. But the system still relied on regionally centralized infrastructure, and that could be censored or surveilled. So I forget what year it was exactly, but the free Bitcoin or the free Blockstream BlockSat satellite service is probably the most well-known and currently operating solution for confirming Bitcoin transactions while off-grid. So using a standard home satellite dish and low-cost parts, anyone can monitor the Bitcoin network from practically anywhere in the world without an internet connection. In fact, Blockstream just announced the version 2 of their system, which makes it even easier. They provide a turnkey kit, essentially, which makes it even easier to set up and sync a full node from the Genesis block forward. So that's been a real revolution. But of course, monitoring the Bitcoin network and confirming transactions is not completely enough. To actually use the Bitcoin network off grid, people also need a way to exchange payment transactions and then to eventually get those transactions to the global network. And that's also true when the internet is too expensive, or it's unreliable, or it's censored, or it's surveilled. So these are all problems that the Blockstream satellite will solve. One half of it, it gets the data to some off-grid location. But how does that user who wants to make a Bitcoin transaction or send a private communication, how do they go back, get that information back onto the internet so it can get confirmed? So this is a GotennaMesh. GotennaMesh powers the world's first consumer mobile mesh network. So militaries have had mobile mesh networks for a long time, but this is the very first time that there's been a consumer mobile mesh device on the market. And it's focused on sending short burst data over great distances. It's around 4 miles, I think, is what we say on the website there. Conditions vary. But it does it in a totally decentralized off-grid manner. So you don't need a cell connection, a Wi-Fi, or a satellite connection. And they're pretty affordable. They're about $80 per device, and they pair with an Android or an iOS device. So messaging is free, and they enable anyone to broadcast over a completely decentralized end-to-end encrypted communication channel using the UHF spectrum. So it's as easy to use as any messaging app on your phone, except for this one transmits on a totally peer-to-peer transport layer. So it will work when nothing else will. So when satellites are down, when the Wi-Fi is down, you can still broadcast with your Gotenna. So here's how a mobile mesh network works. So in a mobile mesh network, devices communicate directly with each other if they're within range. But if they're further away, then that message is going to be relayed from device to device to device until it reaches its destination. So basically, a mesh radio is going to turn your mobile phone into a low-power, low-cost, programmable, decentralized communication infrastructure. So it's really a bottom-up rather than a top-down communication network. Now, in 2018, the Samurai Wallet team created an application that takes advantage of the GotennaMesh as an alternative way to send a Bitcoin transaction to the Bitcoin network. So now, instead of broadcasting a Bitcoin transaction to the internet, a transaction is going to be signed and sent to a mobile application called TXTenna. And TXTenna takes a raw Bitcoin transaction, which is small, on the order of a few hundred bytes, and broadcasts it over the GotennaMesh radio. Transactions are then relayed from device to device, as I mentioned before, until they reach a device running TXTenna that has internet access. So in this way, high-cost metered internet, local internet outages, censorship, surveillance, these can all be routed around using an alternative decentralized communication network. So next, I'm going to show a short movie that just demonstrates TXTenna in action, so you can kind of get a feel for how this is working. So let me just click here. So first thing you're going to see here, there in the lower left corner are the two radios. Now they could be miles apart, but of course in this demo they're right next to each other. And when the lights are blinking, that's when they're sort of transferring information between the two nodes. So here we set up a new Bitcoin transactions. We're going to send 21,000 Satoshis from one device to the other. So there, it's being signed by Samurai Wallet. And now instead of sending it to the internet, we have the option to broadcast with TXTenna. There, so we broadcast it. You can see that hex in the bottom, that's what's getting sent. And then they do a little communication. And once, it may have to send a couple of messages. So once it's done sending those messages, we'll get a confirmation showing that it's been submitted to the network. There we go. So now we have confirmation. So you can see that it's been relayed via the GotennaMesh network to the blockchain, and we have a TX ID, so we have a transaction ID, but it's not yet confirmed. That's the last little bit goes across. Now, next here, we're going to just see that it's in the mempool, so it's waiting to be confirmed by the network. Just show that. There it is. So that's our TX ID. So now we mine. We're going to speed this up a bit, but while that's going on, the node is just waiting for that to be confirmed. Now we're going to skip ahead. Now it's confirmed on the Bitcoin network, so we get a sort of non-authoritative proof back that that Bitcoin transaction is confirmed on the internet. So that's TX10 in action, just to give you a feel for what the off-grid transaction looks like. So you got to note too, as I mentioned at the end there, that confirmation from the gateway at this point with TX10 is only informational. So we get some information, but we don't actually have cryptographic proof that it's confirmed. So that's what we're working on next with the TX10, is to be able to support light clients that are connected over the mesh. So that means that a server, for example, who's connected to the internet could broadcast block headers, Bitcoin block headers from a full node over the mesh network, which would allow a light client to stay synced with the network. And then when a transaction is submitted, as we just saw, instead of just getting an informational message, you'll actually get something called a Merkle proof, which can actually cryptographically place that transaction in a particular block. And it's not as good as, of course, having a full node, but it still gives you a very high level of confidence that that transaction has at least been included in a particular Bitcoin block. Now, there are other ways to connect distant nodes. I just showed you the GotennaMesh, but other examples of communication systems are, you could use, for example, amateur radio, the LoRa mesh network. It's a similar device. The Locha Mesh team, that's Randy Brito. They're a team from Venezuela who are building their own mesh device, low power mesh device for sending Bitcoin transactions. There's also the idea of using low Earth orbit satellites. So obviously you've heard of Starlink from Musk, but there are also others that are much lower power that are being developed. One is being worked on by Eric Lan. He's got a system that can use a very small transmitter and upload Bitcoin transactions, and I guess downlink too. So, so these alternative systems can be used to connect nodes over really great distances. So in the case of high frequency radio, HF frequency radio, that can be thousands of miles. So we've seen tests. Rodolfo Novak, for example, has shown sending Bitcoin transactions from the East Coast to the West Coast of the United States over HF radio. And we also had Sam Pat do the same thing for the initial negotiation of a Lightning communication as well. So in this can, So low Earth orbit satellites, again, are another way to do that. Even if you're in a place that's completely off grid, you can still get that tiny bit of information to a satellite, which can then downlink it somewhere to get it on the internet. So in particular, we've been really working to bring these ideas of low bandwidth messaging over alternative networks to the Lightning network in particular. So this fits really well with the current Lightning protocol, because with only a few changes, we can actually negotiate a full Bitcoin Lightning channel update with as little as 1 kilobyte of data in a total of 3 round-trip communications. So I don't know if you can see that text on there, but the sort of teal version there that's the actual 3 round trips of data. So it's 190, 200, 100, very low amounts of actual data that needs to get transmitted to update a Lightning channel. And that basically, by using such little amounts of data, that's what opens it up to really any sort of long-range communication system, because that's usually the trade-off. There's a trade-off between range, power, and bandwidth. So having it very low bandwidth means things with low power and long range are actually possibilities here. So essentially, this insight about Lightning has led us to develop what we call the Lot 49 protocol. And that's part of our Global Mesh Labs initiative to incentivize nodes to relay text messages using Lightning micropayments. So as a message is passed from node to node, each relay negotiates a small payment that they can collect when a message is delivered. So this is really this is very similar to something called SendPay, which you may have heard of. There's a few different versions of that out there. I think one's called Juggernaut. That's one that's not on mobile, but it's the same idea. So we're basically adapting that for mesh communication. so that you can send a text message over the mesh network, and every node that helps get that message to its destination can collect a small Lightning payment. So this open source initiative is not limited, as I said before, not just to GoTenna radios, because any long-range radio system can be used to connect nodes and even to connect local networks in different countries. So, so this is possible because Bitcoin Lightning nodes that act as light clients, for example, do not require the always-on sort of high bandwidth internet connectivity. So if you were going to do a layer 1 transaction, for example, like with TXTenna, you have to, every time you pay somebody, you have to get that to a gateway, and that gateway over the mesh still, but it has to get to a gateway which goes on the internet, and then in 10 minutes it gets confirmed. So it would be a little bit difficult to use layer 1 to incentivize nodes who relay, because every node who got paid would have to also get a layer 1 transaction, and of course there's fees, and so this doesn't work really well. But with Lightning, it's different. You actually only do one on-chain transaction when you open that channel initially, and then each relay can collect, microcents. As Lightning works now, they collect a small like micro Bitcoin or micro Satoshis for transmitting that message to the next hop. And then that all gets netted out at the end. So if message is going in 2 directions, then maybe it ends up sort of netting out. But this solves various problems. I mean, for example, it solves the problem of one person who just gets online and just continuously broadcasts. I mean, that can happen in the mesh network. And it's not like you can necessarily shut that person down. You can move out of range, but this creates an incentive for people to basically share the bandwidth, to share the radio spectrum in a way that optimizes for everyone. Because if you broadcast for other people, you collect some Satoshis, and if you want to broadcast, you spend some Satoshis. So it creates a nice balance overall. So this is also a place where we think the Bitcoin community can lead the way at creating an alternative communication network for the world. And this is a way, and basically by incentivizing bottom-up communication networks, can not just help off-grid communities to add to their resilience, but it can also add to the resilience of essential communication protocols themselves, including Bitcoin. So by supporting Lot 49, not only do we get the advantages of using Bitcoin Lightning, but the Bitcoin network itself gets the advantage of having a mesh network available to relay transactions, both layer 1 and layer 2. So we think this is a really good way for making Bitcoin more resilient, but also creating really good solutions for communication, both for off-grid communities, last-mile communities, but also just places where you want censorship resistance and resiliency. So we're looking for testers. We're currently looking for people who are willing to set up a mesh network to internet gateway. So there's going to be those gateways we talked about, and just give us feedback as we release an upcoming alpha test version of our Lot 49 app. That's what I'm currently working on. So if you're interested in this idea and you want to test it, let me know. We're also looking help from the development community, where this idea of a low bandwidth block filter based light client is something that really doesn't exist. We've been talking to the Bitcoin development kit team to see if it seems like a good fit for what they're working on. So that would give us a low bandwidth backend that we could use for our Lot 49 mobile application that would already be running a mobile version of Lightning that's adapted for mesh radio and low bandwidth. So I guess if you like the idea of replacing centralized telcos with bottom-up Lightning-powered mesh networks, please get in touch. We're very open to ideas and looking for people to help us make this a reality. So that's it. Thank you all, and if you have any questions, please let me know. You can see there may be a few here in the chat already. Yeah, let me talk. I guess I'll just answer the ones I see here first. So Randall asks, how about Blockstream? Oh, okay, so I guess you wrote that before I wrote. Let's see. Yeah, so how about Blockstream for when the Mad Max days come, if they do? Yeah, I mean, I mentioned Blockstream before. I think that's a really good solution. And I think we can have many alternative Blockstreams. Sometimes there's a criticism of Blockstream because it's it's kind of centralized. I mean, one company is basically broadcasting their version of the blockchain, and if they were ever compelled by a sort of an authority to broadcast the wrong blockchain, they would have to do it. But if you also have somebody broadcasting over high frequency radio, you know, somebody sets up a tower in the Azores and broadcasts their version of the blockchain, and it's got more, you know, work on it than the one you get from the satellite. Now you've got two sources of truth. So that there are many ways to cut that for sure. Let's see, there was another message, another question. So Trent asks, when you develop the upgrade to relay the block headers, for example, yeah, proof back to the originator, will that be a software upgrade? Yeah, that would be a software upgrade to TX10 or some TX10 like application. So TX10 right now is just going to give you the sort of information that it got confirmed in a block, but it doesn't give you proof that it was confirmed in a block. For that, you still need to go on to the internet and get sort of proof from your own full node or some other full node. But the next step to making a light client work over mesh is that we would actually make it talk something like the Electrum protocol so that it could, because that's also a very low bandwidth protocol. We're also looking at block filters. So if you have a little more bandwidth, which is certainly possible, then you could use block filters and be even more sort of self-confirming of your own transactions. So Yo-Yo wrote, sounds like every node is a middleman, gets expensive. Yeah, I mean, it's like the Lightning Network. Every node is a middleman, but we're talking, you know, Satoshis. So this is, or even micro Satoshis. So it can be very small amounts. You can almost, I mean, when it gets sort of these de minimis amounts, it's really just, it's sort of like the idea of hash cash. It's just a way to, if somebody happens to be in a very good place, so if you are the one guy running the satellite uplink, then you could collect some real money because people are willing to pay for that. So in that case, his relay fee might be kind of high. But if you're just a random node out there who's just connecting with other mesh nodes, then your sort of fees could be much lower because it's costing you some battery life, you know, so that's sort of how the fees would be set. But it would be a small fee, and it would also, because you're not confirming every transaction on the blockchain, there's no real like transaction fees. There's no layer one transaction fees. So I think it would be pretty low. Let's see. I see there's a tab here for questions. I'll answer those. So, oh, I see. That's some of those are already there. Oh, yeah, that's cool. About, yeah, they sent a transaction to the space station. So some Dawn here asks, how would the Gotenna communicate with the Starlink sat when available? Well, it would not even know it was talking to a Starlink in that case. Well, let me put it another way. I mean, a Starlink would be like an internet connection. So you would have to have a gateway that talks both to Starlink for the internet and to mesh on the other side. So that would be, but it's a sort of, Starlink is a good way to be off grid, but it's a little bit like a normal internet connection. You have a subscription, things like that. Some of the stuff that Eric Land is working on is interesting because it could be a little bit more like the Blockstream transmission service where people could pay without having an account. So they could just pay with Satoshis. You could literally, I mean, I think his actual goal is to have a satellite, a low Earth orbit satellite that is itself some form of a Lightning node. So it doesn't need a subscription to relay messages. It actually is just another Lightning node that connects a relay fee, probably a higher relay fee than most nodes, but it just collects a relay fee to bounce your message back down to Earth. Last question here I see is using Lightning payments and game theory being used in conjunction with the Gotenna? I'm not sure I quite understand that, but I mean, the game theory involved with Lightning is similar to the game theory involved with what we're doing. There are a few places where it's different because we're actually sending data, and we're more focused on data than transmitting payments. So the game theory is slightly different. We're also ultimately really interested in the L2 protocol version of Lightning because it has some advantages when it comes to making a lower bandwidth protocol. For example, we think that there might be a way that using L2 you could cut down on some of those round trips. So there's currently a proposal right now for combining BIP 118, which is it used to be called no input. Now it's called any previous input or any previous script and input, something like that. And anyway, that's also being proposed. So once Taproot is in Bitcoin and we get L2, we think we can do this in an even more sort of efficient way. So yeah, that's sort of where we're at. And like I said, we're looking for people who want to help. You can go to the Global Mesh Labs website. There's a link to our Telegram chat. So if you want to keep this conversation going, or you have some thoughts, go to our Telegram chat. We're also on Twitter, so follow us on Twitter. As we do things, we'll let you know. We're currently actually looking for ham radio operators because we do have a version that runs over ham radio for sending messages, but we only have been able to get one side of the communication talking, so we need somebody with a good handle on their ham radio rig so we can actually get a two-way negotiation going, just to prove that works. Ham radio would be an example of a gateway. So just like you might use Starlink as your gateway to the internet, you could use ham radio, gateway to ham radio for that. I see one more here. So from Victor. So about mesh networks generally, any thought about the practical limits of broadcasting higher fidelity information such as video over a constellation of bottom-up nodes? So works for BTC transactions, wondering if it could carry. Yeah, that's a good question. So right now, like I said, there's these trade-offs between how much power, how much power it takes, how much bandwidth you have, and how much range you get. But really, the theoretical limits of what you can do is no different than a cell phone. The only difference really between your cell phone, which can obviously do streaming HD video, is, I mean, it's a battery-operated mobile device. So the only real difference is what frequencies you have access to. So we're using this ISM band, the UHF band. It's unlicensed, and it's not the same as what you use for like LTE. So one hope is also that in some areas we might get access to these more bandwidth, essentially get access to different frequencies. And also we are continuously upgrading hardware, finding new algorithms to make our use of the spectrum more efficient. So even using the current GoTenna, we think those will become more efficient and have higher bandwidth. But also, if more people start communicating with mesh, then there could be some pressure on governments to make basically radio spectrum that is in theory owned by the user. It's owned by the residents of that country, rather than auctioning it off to AT&T and then having AT&T sell it back to the residents. Maybe we could just let the residents themselves use some of this, say, LTE spectrum for mesh applications and run their own network, essentially. So that's another way I think we could end up with a bottom-up, higher fidelity, a higher bandwidth kind of network. And that would be, you could use it for Bitcoin, but you could potentially use it for other things, voice calls, video calls, things like that. So it's possible, but first steps first. Well, I think I'm getting a little low on time, but if there's one more question, I think I have time for one more, or maybe we wrap it up.
I think we need to wrap it up.
Sounds good. Okay.
Cool. Thanks so much.
Thanks everyone for coming.